Hello friends, in continuation of the instructional videos on the G100 inverter from LS brand, today we want to talk about the digital inputs of the G100 inverter, multifunction input terminal control. What does that mean? It means what kinds of controls and settings can be configured on the digital inputs, can be performed on the G100 inverter. The first setting that can be configured on the digital inputs of the G100 inverter is the digital input delay select. This means that you can set a delay or filter for the digital inputs, both for when they are activated, turned on, and deactivated, turned off. In other words, after the period you have set, for example, 1 second, if your digital input receives the activation command, 1 second after you issue the activation command, that digital input will become active. Or if you have set a delay for turning it off after you issue the deactivation command, that digital input will be deactivated after the period you have set. To set a delay for the digital inputs, you need to enter parameter in 84 in the G100 inverter, in parameter in 84. As you can clearly see on this detailed diagram of the G100 inverter keypad, once you successfully enter it, you will then observe 5 distinct bits. The very first bit, starting from the right-hand side, is the digital input. P1 is the first bit, the second bit is P2, the third is P3, then P4 and P5. If these bits are set to high, as you can see here, the delay for that digital input is active. If the bit is low, the delay for that digital input is deactivated. So if you want to set a delay, apply a filter or specify a time for any of the digital inputs of the inverter, first you need to activate the bit corresponding to that digital input, starting from the right as we mentioned. It could be P1, P2, P3, P4, or P5, whichever one you want to set a filter or delay for. You need to activate the bit corresponding to that digital input. So that's IN84. But in which parameter? We need to specify this filter, this delay time, and set it up for it to become active. That is, to filter the activation of this digital input, you need to set it in parameter IN85. You should set this duration, which ranges from 0 to 10,000 milliseconds, and its initial default value is 10 milliseconds. That means in the G100 inverter, by default, all digital inputs have their delay activated, and in the on state, they have a 10 millisecond delay. But if you want to set a delay for turning off, that is, for deactivating the digital input, you need to set it in parameter IN86. This one also ranges from 0 up to 10,000 milliseconds. The initial value for the off filter is set to 3 milliseconds by default. So if you want to set a filter or delay time for turning on the digital input, use parameter in 85, and for turning it off, use in 86. Well, another setting you can adjust for the digital inputs of the G100 inverter is to specify whether that digital input is normally open or normally closed. In certain specific cases, such as for a critical emergency function, it is imperative that we require our essential digital input to be typically normally closed as a standard default setting. When the emergency mushroom switch is pressed, that digital input changes from normally closed to normally open. Switching its state to specify whether the digital inputs are normally open or normally closed, we need to enter parameter in 87 in the G100 inverter. When you enter it, you'll see an image like this on the inverter's keypad. Again, the first bit from the right corresponds to the digital input. P1 is the second bit, P2 the third bit, P3 the fourth bit, P4 the fifth bit, and P5 the sixth bit. If these bits are low, that digital input is in no contact mode or normally open. If they're high like this, that digital input is in NC contact mode or normally closed. So for each of the digital inputs, if its corresponding bit is in the off state, meaning it's down, that digital input is normally open. If its corresponding bit is up like this, that digital input is normally closed. So that's how you select normally open or normally closed for a digital input. But you can also thoroughly check in the in90 parameter on the G100 inverter to clearly see which of your various digital inputs are currently active and operational on the G100 inverter, and which ones are inactive or not functioning. So if you want to precisely check the current status of the digital inputs on the G100 inverter, you can easily do so. You need to go into the EN90 parameter and you'll see a screen like this again. If the bit corresponding to any of the digital inputs is active, meaning it's up, that digital input is active, and if it's down, that digital input is inactive. Again, the first bit from the right is related to digital input P1, the second bit is P2, then P3, P4, and P5. Now, as you can see here, the first bit, which is related to digital input P1, is in the on state, meaning its bit is up. So here it shows that right now, my digital input P1 is active. So this covers the status of the digital inputs of the inverter G100 that we can observe. Which of the inverter's digital inputs are in the on state and which ones are in the off state? Let's continue. Let's test all the settings we've learned together on the inverter and get more familiar with these features. So as we said, the first thing we can do with the digital inputs, we can set a delay or filter for the digital inputs. As we mentioned, we can go into the parameter. We enter parameter 84. When we enter parameter 84, as we said, it displays 5 bits for us. Each of these bits corresponds to one of the digital inputs. The first bit is for P1, then P2, P3, P4, and P5. If these bits are set to high, the filter or delay for that digital input is active, and if they're set to low, for example, right now I've set the bit for P1 to low. Low means its filter or delay time is deactivated. If I set it high again, it activates. So each of these bits corresponds to one of the digital inputs. We confirm it. All right, as we said in parameter, in 85, we set the filter duration or the delay time for activating the digital input. For example, it's measured in milliseconds. For instance, here I set it to 5,000 milliseconds, which means 5 seconds. Parameter N86 is for the delay when the digital input is about to turn on. So if you issue the command to deactivate the digital input, after the duration you set in parameter I in N86, your digital input will be deactivated. This is also set, for example, to 3000 milliseconds, which is 3 seconds. All right, now I have activated digital input P1. Now, if I activate digital input P1, the inverter should start after 5 seconds. I have activated it. You can see that after 5 seconds, my inverter started because I had set the delay time for its activation. Now, if I deactivate my digital input, after 3 seconds, this event should happen. The digital input has been deactivated. After 3 seconds, you can see that my inverter stopped. So this is the delay time, or in other words, setting a filter for the digital inputs. All right, as we said, in an 87, I'm going to parameter in 87. We said that with parameter in 87, we can determine the corresponding digital input. Should it be in open mode, normally open or normally closed? We said the first bit from the right becomes P1, then P2, P3, P4, and P5 in order. If we want one of our digital inputs to be in normally closed mode, the corresponding bit must be active, meaning it should be high. If the corresponding bit is low, that digital input will be in normal mode. If this bit is high in parameter in 87, it will be normally closed. If the bit is low, it will be normally open. For example, right now my digital input is active and I set the digital input P1. Normally closed means that in its default state it is closed. You can see that as soon as I set it to normally closed, my inverter went into standby. I also deactivate the digital input. You see that my inverter went into standby. All right then. parameter in 87. We can precisely determine whether the various digital inputs are configured as normally closed or alternatively as normally open circuits. We said that sometimes, like in emergency situations, we absolutely require our digital input to be configured as normally closed in its initial state. This is a critical setting. However, regarding parameter in 90, we previously established that we can make certain adjustments or modifications to its behavior, potentially impacting this initial configuration. The status of the digital inputs. We can observe whether our digital input is currently active or inactive. So, as we said, if this bit, which from the right side is again P1, P2, P3, P4, and P5, if this bit is high, meaning it's active, it shows that our digital input is currently active. If it's active and if it's low, it shows that our digital input is inactive. Now I'm going to activate the digital input P1. Since we set a delay for it, as soon as my digital input is activated, now it shows that my digital input P1 is in the on state, so in the parameter. With this in 90, you can also view the status of your digital inputs. Now I'm deactivating it again. This input, that is, as soon as it was deactivated, the bit changed state and went to off mode. It showed that this digital input is now in the off state.